Okay, so if I'm going to evaluate using sine, cosine and tangent, what I'm going to do is use a combination of the unit circle and the exact values table from what we used in yesterday's lesson. The other thing that comes in really handy here is this diagram. Does anyone want to try and say that as a singular word? ASTC, A-S-T-C. Because this diagram tells me whether sine, cosine or tangent is positive or negative. All right? It's another thing that we've got to remember with circular functions. So I normally give this a name. The name that I use, because it sticks in my head because it's so true, is that all students talk crap. All students talk crap. I don't care how you memorise it. If you come up with some other version in your own mind, that is perfectly fine. If it is completely inappropriate, also perfectly fine if it helps it stick in your head, but I do not want to hear you say it out loud if it is inappropriate. There are some very inappropriate ones that I've heard in the past which are funny, but not okay in the classroom. However you remember it, all students talk crap. That is my go-to. You have to come up with your own. So what this diagram actually means is it means that in the first quadrant, all of sine, cosine and tangent are positives. In the second quadrant, okay, sine is a positive value. That's why it's got a big S, because sine is positive. But cos is negative and tan is negative. So the only circular function, the only trig ratio that is positive in the second quadrant is sine. The only trigonometric ratio, the only circular function that is positive in the third quadrant is tan. And the only circular function or trigonometric ratio that is positive in the fourth quadrant is cosine. So what we're going to do is we're going to use a combination of the unit circle, the exact values table, and this diagram to evaluate our circular functions. All right? This is how it works. The first thing, I start with my angle. So I have to find sine, cosine and tangent for each of the following angles. So I'm going to look at my angle and I'm going to say, all right, what is my reference angle? Where am I starting? This is an easy one that's kind of an odd one to talk about the reference angle because it's just 90 degrees and hopefully we know where 90 degrees is. I'll talk more about the reference angle in the next examples a little bit more. Second step, we are going to work out where 90 degrees is in the unit circle. And to do that, I'm going to draw myself a little unit circle. It does not have to be perfect. Then I'm going to mark for myself, where is 90 degrees? 90 degrees is straight up here. Okay, so now I'm thinking, I know that that is the point where x is 0, y is 1. Or I could go to my exact values table and I can look up when or what is sine of 90 degrees equal to. So I can get it straight off the exact values table. Sine of 90 degrees is the y ordinate. So sine of 90 degrees is 1. What is cos of 90 degrees?
0.
Cos of 90 degrees is the x ordinate. So cos of 90 degrees is 0. And then tan, two ways that we can do tan. Option number 1 is I can do sine divided by cos. Option number 2, I can look up my exact values table because tan of 90 degrees is in my exact values table. And tan of 90 degrees is undefined. Okay, that was the easy one. Second example. I actually want to do this one, 7 pi over. So first thing, step 1. We're going to talk about the reference angle. So when I talk about the reference angle, In our exact values table, we have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Or we have 0 radians, pi on 6 radians, pi on 4 radians, pi on 3 radians, and pi on 2 radians. So for my reference angle, I'm going to kind of compare this to one of them. And it's really easy to work out which is your reference angle. I'm just going to look at my denominator. My denominator is a 4. So my reference angle is going to be pi on 4. All right, we just use whatever the denominator is. Second step, I'm going to work out where this is. Where is 7 pi on 4 in the unit circle? To do that, I'm going to draw myself a little unit circle. And I'm going to say, all right, well, my reference angle is pi on 4, so that's there. But I don't want pi on 4, I want 7 pi on 4. When you get good at knowing where your angles are, some of you will be able to jump straight to 7 pi on 4 and know it's over here. All right? There's a couple of ways, a couple of shortcuts that you can work that out. But if you're having trouble, I'm going to just tell you to count them out. This is 1 pi on 4. This is 2 pi on 4. 3 pi on 4. 4 pi on 4. 5 pi on 4. 6 pi on 4. 7 pi on 4. Okay, which quadrant are we in?
C.
We are in C. What does C mean?
Cos.
It does mean cos. What is this telling me? This is telling me that when I am in the fourth quadrant, the only ratio that is positive is cosine. Okay, in this quadrant, sine is a negative value. In this quadrant, tan is a negative value. In this quadrant, cos is a positive value. So what we're going to do, we're going to work out what is sine of 7 pi over 4. Now, because it's in the fourth quadrant, and because our reference angle is pi on 4, we know this has got something to do with sine of pi on 4. So what I'm going to write, this is what I'm trying to find, sine of 7 pi on 4. Because my reference angle is pi on 4, it's got something to do with sine of pi on 4. But because I'm in the fourth quadrant, over here, sine is not positive, sine is negative. So I can say that sine of 7 pi on 4 is the same as negative sine of pi on 4. And then I look up my exact values table. From the exact values table, sine of pi on 4 is root 2 over 2. So my answer for sine of 7 pi on 4 is equal to negative root 2 over 2. And you would have that in your unit circle that you've drawn on your sheet that you can stick in your summary journal. All right. But when it's technology free and note free in an exam, you're probably not going to remember that whole circle, but you can remember the exact values table. That's a smaller set of values. Okay, let's go to the second one. Cos of 7 pi on 4 has something to do with cos of pi on 4 because this is my reference angle. Now, I've just got to decide, is it positive or negative? Because I'm in the fourth quadrant, is cos positive or negative?
Positive.
Positive. So cos of 7 pi on 4 is equal to positive cos of pi on 4. And then I look up my exact values table. What is cos of pi on 4 equal to? It is equal to root 2 over 2. Do I need to write the plus sign? Nah. So I'll get rid of that. So that's my answer for the second one. Third angle I've got to find. Tan of 7 pi on 4. And I feel like I'm drifting off to the side here, so I'm just going to bring it over so we're in the video. Tan of 7 pi on 4. has something to do with tan of pi on 4. Except 7 pi on 4 is in the fourth quadrant. So I go over to ASTC. In the fourth quadrant, is tan positive or negative? Negative. It's negative. Only cos is positive over here. So tan of 7 pi on 4 is the same as negative tan of pi on 4. And then I look up my exact values table. What is tan of pi on 4 in our exact values table? It is 1. So that is my answer. Starting to get there? All right, let's do 2 more examples. Ready to go? Yep. A few people taking notes still. All right, so my angle is 17 pi on 6. I want to find sine, cosine and tangent. First step, find my reference angle. And I'm going to cheat. I'm going to say reference angle. What angle in my exact values table has this got something to do with? Pi on 6. It's always just the denominator. This is a 6, so we're going to work with pi on 6. So my reference angle is pi on 6. Second step, where is it in the unit circle? So I draw the unit circle. And I know it's got something to do with pi on 6, which is down here at 30 degrees. Now there's a couple of ways I can work out which is 17 pi on 6. There's lots of shortcuts that you can take, but I'm just going to count in lots of 30 degrees at this point in time. All right. Actually, no, I'm going to jump ahead a little bit. We know that this is pi over here, yeah? So that would be 6 pi on 6, wouldn't it? And we know that over here is 2 pi. So 2 lots of pi would be 12 pi on 6. So this is 12 pi on 6. And then I've got to count from there. So then that would be 13 pi on 6, 14 pi on 6, 15 pi on 6, 16 pi on 6, 17 pi on 6. Or you could have known that I went 6 pi on 6, 12 pi on 6, 18 pi on 6. I'd have to go back 1 pi on 6. So there's lots of ways I can work out the location. I can make jumps. If you're having trouble, literally count them around the circle and I can help you do that. This is 17 pi on 6. Which quadrant is it in? It is not in the first quadrant. It's in the second quadrant. So all students talk crap. Sine is the only one that's positive. So I'm going to say sine of 17 pi over 6 has something to do with sine of 1 pi on 6. What has it got to do with 1 pi on 6? In this quadrant, sine will be positive. Then I look up my exact values table. What is sine of pi on 6? It is 1/2. And this is where we've got to start memorising that exact values table so you don't have to look it up every time. The goal is to do this without a calculator and without notes. Move to the second one. I want to find out what is cos of 17 pi on 6. We know it has something to do with cos of 1 pi on 6 because that's my reference angle. In the second quadrant, sine's positive. What's cos?
Negative.
Negative. So all I'm going to do is I'm going to stick a negative in here. And then what is cos of pi on 6 from your exact values table? It's root 3 on 2. So my answer is negative root 3 on 2. And because I've run out of space, I'm going to chuck tan over here. Tan of 17 pi over 6 has something to do with tan of pi on 6. In the second quadrant, is tan positive or negative? Negative. So I stick my negative in. And then I look up my exact values table. What is tan of pi on 6? Tan of pi on 6 from your exact values table is It's not the square root of 2. It's not 2. It is 1 over square root of 3, and my answer is a negative. Better is to rationalise your denominator. In maths methods, you are expected to rationalise your denominator to get full marks. It's like simplifying fractions. So you should write negative root 3 over 3. If you do not know about rationalising denominators, I can talk to you about that at a different time though. So this was my final answer for tan. Rub this out. Last example. I feel like we can go a bit faster now. So first thing, I find my reference angle. My reference angle has something to do with the denominator. So my reference angle is pi over 3. It's going to have something to do with pi over 3. Second step, I work out where is negative 7 pi on 3 in the unit circle. So I draw a little unit circle. And remember from our lesson when we were next door and we did the chalk on the floor, if we had negative angles, if we went around the unit circle in an anti-clockwise direction, they were all of our positive angles. So to get my negative angles, I have to go around the unit circle in an anti-clockwise direction. I'm going to go this way instead of this way. Normally, pi on 3 is up here at 60 degrees. All right, because that angle has gone anti-clockwise 60 degrees. For negative angles, we're going to go the opposite direction. So we're going to go minus 1 pi on 3, minus 2 pi on 3, minus 3 pi on 3, minus 4 pi on 3, minus 5 pi on 3, minus 6 pi on 3, minus 7 pi on 3. Now my hint here, if I do one loop anti-clockwise, it would be minus 6 pi on 3, because that's the same as minus 2 pi. So I often jump to 2 pi and 1 pi to help me speed up that process of working out where it is. Okay. We're in the fourth quadrant. Oh, students, talk, crap. What is positive in the fourth quadrant? Cos. So I go sine of negative 7 pi on 3 has something to do with sine of pi on 3. Because we're in the fourth quadrant, it's going to be negative. And then I look up the exact values table. What is sine of pi on 3? It's root 3 on 2, and it's negative. Cos of negative 7 pi on 3 has something to do with cos of pi on 3. That something, because I'm in the fourth quadrant, is just that they are the same. It is positive. And cos of pi on 3 from the exact values table is 1/2. And then finally, because my spacing isn't great, tan of negative 7 pi on 3 has something to do with tan of pi on 3. And because we're in the fourth quadrant, tan is negative. And then I look up the exact values table. Tan of pi on 3 is root 3. So it's negative root 3.